Today we're going to create the final component specifically for our sword, the PoiseDamage component. Poise is a stat that our entities have that determines how many hits it takes before they can get stunned. It works very similarly to health, except that instead of dying when it reaches 0, the entity is stunned. And unlike health, the Poise stat regenerates automatically. So welcome to Bardent, my name is Heinrich, and let's jump into part 15 of the multi-weapon system series. So just like before, let's first start by creating our 3 main scripts, starting with the class that represents the data for a single attack. So let's head go ahead and head over to our IDE. And the first thing I'm going to do is open up my File Explorer, open up the Weapons folder in the Scripts folder, come down to Components, Component Data, and Attack Data. So in the Attack Data folder, go ahead and create a new C# class, and this one I'm just going to call AttackPoiseDamage. Now this class is going to inherit from the Attack Data class, and because this is the data that we edit in the inspector, we need to make sure and add the serializable attribute at the top of the class. Now, what is PoiseDamage? Again, it's basically just like normal damage. It's just a float value that gets subtracted from some stat. So let's go ahead and create a field, serialized field, so that we can see it in the inspector, and create a public float called amount, and then give it a public getter and a private setter. So that is the base data class. Next, we need to go ahead and create the class that represents the data for the entire component. So in the component data folder, right-click on that, hit add, new C# class, and this is going to be called PoiseDamageData. Now this class is going to be inheriting from the component data class. And the generic parameter that we're passing in is the AttackPoiseDamage that we just created. And so now because we are inheriting from component data, that means that we are required to implement this missing member, which is the setComponent dependency, and this is the mono behavior associated with this weapon component. So we need to say component dependency equals type of, but we haven't yet created this class. So let's go ahead and do that quickly. So over here in the components folder, right-click on that, hit add, new C# class, and this is just going to be called PoiseDamage. Now with that created, before we do anything in here, come back to PoiseDamageData, and the type of here is PoiseDamage, like that. And that is everything we need to do for both of our data classes. We can now focus on just PoiseDamage. So let's head back to that class and let's quickly talk about it for a second. This class is going to work very similarly to both our damage and knockback classes. So that means the first thing we need is a reference to our action hitbox component. So let's go ahead and declare a variable for that. So that is private action hitbox, call it just hitbox. And then we need to go ahead and set this reference in our start. But I notice now that I forgot to inherit from our component class or weapon component. So make sure PoiseDamage inherits from weapon component. And here we need to pass in 2 types for our generic. The first is the component data, so that is PoiseDamageData. And next is the attack data, so just AttackPoiseDamage. Okay, now we can go ahead and override our start function. So just protected override void start, and after base.start we say hitbox equals getComponent, and the type we're looking for is our action hitbox. Now our action hitbox has that event that it fires off when it detects something within the hitbox, so we need to create a handler for that. So up here, let's just go ahead and create a private void handle detect collider2d. And this has an input parameter of collider2d array called colliders. So now we have a handler function for that event. Let's go ahead and subscribe this handler to that event. So back in start, after getting a reference to the hitbox, we can say hitbox.onDetectCollider2d plus equals handle detectCollider2d. And now because we subscribe to this event, we need to make sure we unsubscribe And we're going to do that in the onDestroy function. So go ahead and override that. And then we can say hitbox.onDetectCollider2D minus equals handle collider2D. Okay, so back up in our handle detect collider 2D function, let's talk about this logic again. Again, all we're going to do is we take this array of colliders, we're going to iterate through it and look for a specific interface. In this case, the IPoiseDamageable interface, which we have not yet created. Whenever we do find that interface, we're going to call a specific function and pass that amount from our attack data. So let's just go ahead and do that. We can go ahead and say for each. And the collection we want to iterate through is our colliders. Keep that as var, and I'm just going to call each one item. Now in here we can say if item.tryGetComponent, and then we need to give it the out keyword, and the type we're looking for is the IPoiseDamageable, which again we have not yet created, so we'll do that in just a second, but we'll just call it PoiseDamageable. If this is true, we're going to say PoiseDamageable dot damage poise. And to this function, we're simply going to pass our attack data amount. So we can say current attack data dot amount, like that. And that's basically all the logic for this component. So now we just need to go ahead and create this interface, and then we have some other setup to do on our enemies to make this work. So let's go ahead and open up our File Explorer, and let's come up to our interfaces folder up here. So here we have our iKnockbackable and iDamageable. Go ahead and create a new C# class. I'm going to call it IPoiseDamageable. And over here I can just select interface. Now I'm actually going to rename my namespace here and just get rid of scripts. I just want it to be bardent.interfaces, like that. Okay, so for this interface, what do we need? Well, we just have that one function. It is a void, so it has no return type, and we just call it damage poise, and it simply takes in a float called amount. Like that, and that's it for the interface. So back in our component, we now just need to make sure that we include the correct namespace, so full stop on that, and that made sure that we included using bardent.interfaces. And so that's basically it for this component. But unfortunately, unlike the damage and knockback components that we created earlier, we're not quite done yet. So if we take a look at our damage component over here, you can see it's exactly the same thing. We iterate through the colliders, we look for this iDamageable interface, and then we call the damage function. So that means we need a mono behavior that is implementing iDamageable. And in our case, we have just that over here in the cores. So if we look at our core components, we have this DamageReceiver function. If we take a look at that, as you can see, it is a core component, which is actually just a mono behavior with some other logic over here for us. But you can see over here, it implements the iDamageable interface. And over here is the damage function that comes from the iDamageable interface. So you can see over here, all it does is it interacts with the stats core component and calls the decrease health function passing in this amount. So we need to go ahead and create a new core component for our enemies, and our player can also use it, but we're not going to implement stun state on the player just yet. We're just going to hook it back up on the enemies because we've created it earlier in the series. So we need to create a new core component. Let's go ahead and come to our core components folder, right click on that and add a new C# class. And I'm going to call this PoiseDamageReceiver. Now for this class, I want to make sure that this is a core component. So inherit from core component, and we want to implement the IPoiseDamageable interface, like that. If we go ahead and hit Control full stop, we can say implement missing members, which will just auto-generate that poise damage function for us. And I'm going to go ahead and get rid of this exception. Now, what do we want to do in here? So, as I mentioned before, poise is a stat. It's a stat that our entities have that is very similar to health. So, we want our PoiseDamageReceiver to also interact with our stats core component. So let's go ahead and quickly take a look at our stats core component. You can see over here that our stats core component currently only implements health. So we have this max health variable that we can set from the inspector and a current health variable that just keeps track of the current health. We also have this event that gets fired off whenever the health reaches 0. That way our player or entities can die. So I want to go ahead and add this poise stat here, but I don't want to rewrite all of these functions because we have a decrease health function and an increase health function and the actual variables up here itself. So I think what we should do is create a new class that is just a stat that has all this information here, and then we can just hard code our actual stats in here for now, if that makes sense. So let's go ahead and come back to our File Explorer, and in the core folder, I'm just going to create a new directory, so a new folder, and I'm just going to call it stats, like that. It doesn't really matter where you place it, I'm just putting it here because for me only the core components are going to make use of this. So inside the stats folder, let's go ahead and create a new C# class, and we'll just call it stat. So this class is going to be the representation of a single stat, and we can reuse this class for all of our different stats. Now you can see I currently have an error here, and that's because this folder is called stats, even though I have a stats core component. So let's actually just rename this to stats system. So let's talk about our stats again for a second. Well, the first thing I want is I want to be able to set the stats in the inspector. So we need to make sure that this has the serializable attribute at the top. And now the first thing that I care about is what this stat is initially set to. So its maximum value. So let's go ahead and create a field, serialized field, public float, max value, and give it a public getter and a private setter like that. Next, we need a variable to keep track of what the current value is. So let's create a private float called current value. Now, obviously, we probably want other classes to have access to our current value, and we're going to do this with a getter and a setter. So let's create another public float called current value with a capital C this time. And for this, we're simply going to say get returns current value. But when we set, what I want to do is I want to say current value equals mathf.clamp, and I want to clamp the value coming in between 0f and our max value, just so we make sure that whenever we mess with our current value for the stat, we never go outside this range. And now the next thing we can actually do here is whenever this value does reach 0, we can go ahead and fire off an event. So at the top here, let's just go ahead and declare a public event action, and we'll just call it on current value 0. And then back in our current value setter, we can say if current value is less than or equal to 0f, then invoke the on current value event. Cool. So now we just need a function to initialize our stat. So let's create a public void, call it init, and all this function does is it says current value with the capital C equals max value. Then we need two functions to increase and decrease the current value. So first one is going to be public void increase, and this takes in a float amount to increase by, and all this does is say current value, again with a capital C, plus equals amount. And next we have public void decrease, float amount, and all this does is current value minus equals amount. And that keeps things nice and simple. Our setter here takes care of making sure we never go above our max value, and also takes care of invoking our event whenever the value does reach 0. So that is a pretty good representation for a stat. Let's go ahead and come back to our stats core component. And in here, we can go ahead and actually just get rid of almost everything. We don't need these decrease, increase health functions anymore. So I'm left with just the override or the awake function. Now, let's go ahead and just re-implement our health. So here we can go ahead and say field, serialize field, public stat, and the first one is going to be our health stat with a public getter and a private setter, and it looks like it didn't add the reference, so do that. So that just means we need to make sure we're adding using pardon.coreSystem.statSystem. So if the health variable now created in awake, we can go ahead and say health.init. That just makes sure that the current value is being set to the right value. And that's basically it. So now we just have a couple of errors to fix where our other components were interacting with the stats system to work with health. So the first one is our damage receiver. So over here you can see we said stats.comp.decrease health, which again, if you remember in the previous episode, I said that this core comp thing is not really needed anymore. So I'm just going to refactor that now whenever I see it. Again, it's not too important. It should work. We can do that. Come down to awake. And now stats simply equals core.getCoreComponent. And the component we want is stats. And the same thing for our particle manager. So core.getCoreComponent particle manager. Okay, so that means in the damage function, I can go ahead and instead of calling stats.comp.decrease health, we're going to call stats.health.decrease, passing in the amount. And now this error for particle manager is unrelated to stats, it's just the fix that we made here, so we can get rid of comp and have it just like that. Perfect. Okay, so that's all the errors fixed in our damage receiver. Next, we have an error in our death core component. So here we were subscribing to that onHealth0 event. So here all we have to say is stats.health.onCurrentValue0 plus equals die, like that. And just like that, our health is working again. So it's just as simple as that to add a new stat. So that means we can come back to our stats core component now, and we can go ahead and add our poise stat. So let's create another field, serialize field, call it public stat poise, and again public getter and a private setter. And the first thing we do in awake is we say poise.init. Now if you remember earlier I said that poise is different from health because poise regenerates automatically. So what we can do here is let's create a serialized field, private float. We'll just call it poise recovery rate. So this is the amount that we want to increase the poise by every second. And we can go ahead and just override our update function. Actually, just implement our update function because I don't think core component itself makes use of update. So just private void update. And in here, all we say is if poise.currentValue equals poise.maxValue, then return. So if our current value for poise equals the max value, meaning our poise is full, we don't have to do anything. Otherwise, we're going to say poise.increase by our poise recovery rate multiplied by time.delta time. And the reason we multiply it by time.delta time is just to make sure that it increases consistently no matter what our frame rate is. So with this poise stat created, that means we can now come back to our PoiseDamageReceiver core component. And here we can start off by getting a reference to our stats core component. So we'll say private stats, and then we can go ahead and override the awake function. And after base.awake, we say stats equals core.getCoreComponent, and the type that we want is stats. Then with that reference set, we can come to our damagePoise function, and in here all we say is stats.poise.decrease by amount. Okay, so now we have a PoiseDamageReceiver core component that takes care of decreasing the relevant stat, but our enemies aren't really going to react to this yet. For one, we still need to add the PoiseDamageReceiver to the actual game object, but there's also no code yet in place to actually deal with this information. So what we need to do is we need to revisit some of our old enemy code. It's not a lot, and again, if you're not coming from the player controller series, you might not have this. But if you want to know more about it, I recommend checking out this specific part of the video. I'll link the first part at the top right now. But just to give you an idea of how we can use this, the first thing we need to do is open up our state machine folder in the enemies folder and come to the entity class. So this entity class was the base class for all of our enemies. And now we had an old way of stunning our enemy before that made use of this isStun boolean and things like that. I'm not going to bother refactoring this. The enemies need a big refactor anyway. But just to show you how we can make use of it now, what we can do is let's go ahead and reference the enemy's stat in this entity script. So let's create a protected stats like that. And then in the awake function, after we get a reference to our core, we can go ahead and say stats equals core.get core component stats. And so that means now that both of our enemies that we've created so far will have a reference to this stats core component, which means we can now come to our enemy specific folder, come to enemy1 and open up the enemy1 script. So here is where we declared all the different states for our enemy, and you can see we have this stun state. So what I'm going to do now is after I create all these states, I want to create a transition to the stun state whenever the Poise stats on current value 0 event is invoked. So first of all, we need a function to handle that event. So after the awake, I'm just going to create a private void handle Poise 0. And all this function does is it says state machine dot change state to the stun state. Now in the awake, what I can do is I can say stats dot poise dot on current value 0 plus equals handle poise 0. Now again, just because we're subscribing to this event means we also need to unsubscribe from it. And the best place to do that is going to be in the onDestroy function. So go ahead and say private onDestroy. And in here, we can just copy this, paste it in here, and change it to minus equals. So that does it for enemy 1. We just need to go ahead and do the exact same thing in our enemy 2. Now what I'm going to do is I'm just going to copy this and then come to enemy 2. Get rid of this squiggly bracket because I copied it and paste this in here. So now our enemy 2 also has access to this stats variable, and we're doing the exact same thing. And now we just need to remember to unsubscribe from this event. So we can say onDestroy, and then here's stats.poise.onCurrent value 0 minus equals handle poise 0. And that's basically it. I know this might be a little bit confusing with the enemy stuff I'm pulling in later, but this is just showing how this poise stat is being used. And hopefully, if your enemies work completely differently, you can see how you would use this. And thankfully, if you don't have poise as a stat in your game, you can just ignore this section completely. You don't have to add that component to your weapons. But so with that done, we just have some final setup to do within Unity, and then we can test. So let's go ahead and come back to Unity. And the first thing we need to do is come to our player, open up the core, come to our stats core component, which you can see we now have health and poise, but all these values are both set to 0. So I'm going to set both the health and the poise to 100, and I guess set the poise recovery rate to 25. Again, it doesn't matter on the player yet, I just want to do it now so it's ready. We just need to make sure we also do the same thing for both of our enemies. So select the stats game objects, and of course you set your health and poise values to whatever you want. I'm going to set the health to 50 and the poise to 25. And I'll make the poise recovery rate 5. And so now our enemies should be able to get stunned. The last thing we need to do is actually add our poise damage component to our weapons. So let's come back to our weapon data, select sword 1, add a new component, and the component we want is PoiseDamageData. If we expand that, we have our 3 attacks. Now, I just want to see if they get stunned, so I'm going to make the poise damage like 30, so that it's higher than what their actual poise is. And for sword 2, add component, PoiseDamageData. I'll make this one like 20, so that it'll take both hits to stun the enemy. That way we can test if the poise recovery is also working. Perfect, so now we can go ahead and not run the game yet. There's one more thing we need to do. We need to come back to our hierarchy, and we need to come to both our enemy 1 and enemy 2 combat game objects over here. And we need to say add component, and we want the PoiseDamageReceiver component. That way we can actually find that interface. So now if we run the game, everything should work. Fingers crossed. Let's try it out. So if we come to our enemy 2 and hit him with our sword 1, you can see he got stunned and he recovers. And if I hit him with my sword 2 twice, he gets stunned. Perfect. So that's our poise damage. We now have the ability to stun our enemies. But so yeah, that's going to do it for this episode. And that is the last component that we're creating specifically for the sword. So in the next episode, we're probably going to move on to our bow and working on the ranged components that spawn projectiles. So I'm super excited for that one, and I hope you are too. If you would like access to the prototype that I'm using for this series, it is available to all of my Patreon tiers over on Patreon. And with that being said, I would just like to say thank you to all of my supporters and wonderful people over on Patreon, and a huge special thank you to Cody Lee, SM, Major Sins, Jake Skarupa, Patrick, Atami, Mike Rodriguez, and Nathan Ackley. You guys are absolute mad lads, and I hope you all have a wonderful day.